So just to add a little bit more to the introductions before we dive in, let's see, Lieutenant Colonel Raven LeClair is also an autonomy specialist and big advocate and spends a lot of his time thinking about the very things we're going to be talking about today. And Colonel Hansberger is now the director of the Department of the Air Force Stanford AI Studio with the goal of advancing AI research that could benefit the Air Force. So just to frame it even more. And I should make a joke about a conference joke for the last thing between you and lunch. We know that. But we're excited to talk about the future of AI in the Air Force today. Okay, so looking back over the past 4 years, we'll start there. Ukraine has showed us that $500 drones can threaten, $10 million, $100 million platforms, and really has been making low cost and autonomy some defining features of this war. So to my panelists here, what Air Force assumptions have been disproven over these past several years?
Okay, sure, I'll start. I think maybe our conception, I would say probably 4 or 5 years ago, was that the future character of warfare was going to be very high-end, very high-tech, information, data kind of warfare. I think the return to the trenches in Ukraine kind of disproved maybe that theory in a pretty dramatic way. I don't think any of us anticipated that, over the course of the war, that it would return to this kind of like trench warfare, and that a greater power, the bigger power wouldn't be able to establish air superiority in a way that allowed them to just kind of patrol the skies freely. I think both those things, if you would have asked me 5 years ago, I never would have imagined that this is the kind of the character of the fight would have gone this way.
Yeah, Raven?
Yeah, I don't disagree at all. I want to thank you for having us here as well, Reza. Thanks so much. It's super exciting to be talking to an audience of brilliant people. It's humbling, really. I would agree. I would say that it's extremely nuanced as well, in that we all probably thought the next war or wars were going to be really deeply based on not just data, but also autonomy. And I would say that we proved that we're not yet ready for autonomy, but automation, it took a giant leap forward. And what I mean by that is when there's still people in the trenches shooting drones out to go kill very expensive war machines, using automation, but not full autonomy in that sense. We're getting there, but it proved that it actually doesn't take full machine learning, full AI to go be very effective. You just need a little bit. It's a tool, and we just need to continue to figure out how to use those tools effectively.
Yeah, and maybe it's also, I don't think anybody would have thought, or we would have had a theory of kind of the character of warfare would not be a repurposing of a general consumer device into kind of the defining weapons platform for, essentially like a full-scale war. That's super surprising, I think, to everybody, that the things that we made specifically for warfighting got beat by a kind of a reimagination of an existing means to the desired end.
Yeah, Jason, I think it was you in a podcast that I was listening to as part of my research here. You had a good analogy about having to run out for formula, and that you in a snowstorm, and if your only tool, well, maybe you can speak to that adaptability point.
Yeah, so this is a kind of an annoying but maybe useful vignette that I use to talk about how we develop AI or what we need to do it in a useful way. So, okay, in this vignette, it's a Sunday morning, I wake up and my wife looks over at me and she says, "We're out of baby formula, you need to go to the store to get some." And so, as a military officer, I'm gonna do my mission analysis, and the first thing I realize, we've had a logistical failure, but that's kind of aside from the point now, the mission is the mission, and we got to get the baby the food. So I walk up to my car, and when I get there, it's snowing. And I think in a traditional sense, it's easy to stop there and say, what's the problem? And I think this leads us to a very exquisite solution, because if we say the problem is, I need to get to the grocery store no matter what, no matter the conditions, then what could happen is, okay, well, what do I need for that? Well, I need a 6-wheeled vehicle with all-wheel drive, a snow plow, and some embedded autonomy in case I'm hungover from the night before. No matter what, I got to get to the store. And in the traditional sense, like, okay, yeah, our war plan says this is what we need, and then we go talk to a big prime, and they develop the thing, and it takes 8 inventions to field it, and 30 years later, we're hoping that it's IOC. But the mistake we made was like confusing an environmental analysis for an engineer or an actual problem. Because the actual problem, now if you brought this problem to somebody in Canada, they would say, the problem is just the coefficient of friction between your tire and the road. And actually, there's a lot of existing solutions to this. There's both mechanical and chemical solutions. You could put studs on the tire, or chains, or salt, or sand. But it's that knowing and being around the technology or being around the environment that makes them so good at identifying the actual problem. And if you brought this problem, to Puerto Rico, or to Ecuador, wherever, name your tropical place, they would probably agree that the problem is environmental conditions change and you need to do that. And so, when I think about one of the purposes that we're here and why it's important to have the Air Force embedded at Stanford and in Silicon Valley, is that it gives us the opportunity to become knowledgeable about what's being fielded and why that works and why that doesn't work. And we just have a much better understanding of what means exist. And if you understand the means that are out there, you also understand what problem those things were developed to solve and whether or not that translates to the problem that we have in the military. And I think for the Air Force, this is something that we're trying to evolve to, is a better understanding in a general sense of what's available in AI autonomy and how we can reimagine those existing means, like a drone, to the desired end. But the drone and AI are different things, but it's the same sense of once you get into the problem, there's probably already some kind of technology that can help you, and we don't need to develop it from scratch.
Yeah, I think generally I agree with you, but yesterday I spent the day at a Special Operations Forces technology workshop where there was just this sense of frustration that getting US-made or NDAA compliant drones, so the hardware, the software, things like video transmission and receipt, everything is just bad or worse than you can get from even hobbyist grade Chinese equipment. And so wanting to be adaptable and flexible in platforms requires that the quality and performance and features are all there. So how do we make sure that we raise the bar for AI in that sense?
I mean, I think it's a risk calculation. Do we absorb, or do we mitigate more risk by ensuring that our entire supply chain, both algorithmic, software, hardware, is US owned only? Can it be US and ally owned? Is that secure enough? And is that going to grant me more security than fielding the very kind of best, most performant technology available, either hardware, software, algorithmic? And I think the question is it's a risk decision. Do I beat my enemy by fielding the very best, the very quickest, and potentially expose myself to some kind of supply chain vulnerability? Or do I beat my enemy by, and hopefully we don't have to make this choice, but I think we are now, is by fielding more expensive, less performant things that I have better assurance of the security on those. In Ukraine, I think the answer is whatever gets out the thing the fastest keeps you alive the best. And so, they've adopted whatever they can get to use, they use.
Yeah.
If the problem statement is how do we get advanced technology to the warfighter faster, then the warfighter is going to inevitably come back very quickly of, did you actually listen to me and give me what I asked for? And so often we don't. So often we spend that 8 years developing something that actually the requirements from the very beginning were flawed. And so really it's that speed of iteration that they've proven in Ukraine to adapt and solve every single problem where that loop has become weeks or less versus the years that we've dealt with. And I think that the DoD and our warfighting capability has been fundamentally built around evolution of years. and not weeks.
Yeah.
And when we're talking about AI now and software, if it takes us years to train a model and then it doesn't work and we've promised a lot of things out of it, then we'll be doing our warfighter a disservice, as we have again and again previously. So we have to break the model of acquisition to really leverage advanced technology, commercial capabilities, or specific to military capabilities, I believe.
Yeah, and I mean, this goes right back to the defining the problem, because we can't have good requirements if we can't define the problem, and we can't define the problem if we don't have the right technical talent put against the effort. And so I think, like I said, like a big part of us being here is accessing, ideally building the organic talent within the Department of the Air Force and within, the broader department and within the defense industrial base or the entire defense community. Because I don't think that that's where most of the most exquisite talent lies within that community. It's, it's influencing other communities to help us do the same.
Yeah. In that podcast I mentioned, and Raven also one that you spoke on recently as well, you both talked about how the sort of sensible entry point for AI is to maximize human cognition. And I certainly, if I were the kind of person that might disagree with you both, which I don't think I am, it seems unwise, but I might say that certainly for certain systems and programs and, Raven, like the F-35, if you tried to just pluck the pilot out and just introduce AI, that whole program would fall apart and we wouldn't get anywhere. There are other places and examples like I learned a new acronym, HAWS, I think it was. Somebody remind me of something, autonomous weapon, highly autonomous weapon systems.
Yeah.
So, yes, let's maximize human cognition in some of those specific cases, but across the board to have that be the, philosophy for the Air Force as far as AI adoption and making that very structural, that it's, coming in these entry points that are just to support the humans that we'll keep in these positions by and large. There are going to be, costs to that decision and that philosophy in the form of, potentially lags behind other nations throughout the world. So how do you think about that?
Make sure I understand the question, but you're saying in terms of introducing the new capabilities where we replace pilots or operators and where we don't, what is the best approach on how do we do that without breaking the system and or disabling our capabilities along the way? Yeah,
because, there's the human first approach, and then on the complete other end of the spectrum, there's, the AI first approach.
Yeah.
And we know where some other nations might decide to go and the approach that we're likely taking here.
Yeah, got it. I'll take a stab at it. I think from the tactical level, and I mean flying the aircraft, employing the weapons against the right target to achieve a tactical objective which will lead to a strategic goal. In that context, it's all about workload. It's how much can we offload on the automation to make it so that the pilot can be making hard human decisions and the aircraft and the AI and anything else you're doing is doing the stuff that it's good at. So it's that teaming approach. And going back to Vietnam, we have these examples where you had two people in an aircraft and a wild weasel. One of them was interpreting raw signals from SAM emissions, surface air missile radars, and trying to locate them and geolocate them and point them. And that was one person's job. The other person was flying the airplane and making sure you didn't get shot or avoiding incoming missiles. We've now evolved to where a single seat fighter pilot can do that same job because all the algorithms behind the scene are fusing together the tactical data picture for them. They know where the threat is. They can make decisions based on what the computer is doing behind the scenes to give them the right information. And I think it's just that spectrum. And every time we take a giant leap in new capability, we now have to reassess what is the role of the human and what is the role of the machine. All the way back to the autopilot. Like I spend a lot of my time not flying the F-35, letting the autopilot do that for me so I can do human task things that don't include watching my airspeed, watching my altitude. The computer's great at doing that. I'm gonna let it do that. So with AI and machine learning things, I think it just now is another opportunity to take that giant leap of how many more tasks can we offload to it so I can do what I do best and it can do what it does best. If we take that approach, I think we'll do correct decision making, and whether that be an autonomous platform or a piloted aircraft like an F-35, there's going to be a time and a place for that bar to move. But in general, we need humans to be making those harder decisions, whether they be strategic, commander's intent, life-taking type of decisions. We want humans there. But when it comes down to the mechanics of executing it, I don't want to hand fly a missile into another aircraft. That's what computers are for.
Yeah, I think it's a question. Maybe the first question is a question of dimensionality and complexity, and how performant is the algorithm, and is it trustworthy to carry out the task? Like, my dishwasher does a really good job of replacing a human because it's a box that does a thing, and there's no intervention required. It's fully autonomous. Maybe our earliest fully autonomous weapon is like a landmine. And we decided as a society that it's okay to use those, and then we didn't because essentially there's no bounding on time for the landmine, right? And so I think when we think about what is best suited for autonomous tooling or AI tooling, it's those things that are low dimensionality or bounded pretty specifically by time and space. And so maybe the example to use would be that now in Ukraine they're fielding drones that are able to fly and then use automatic target recognition to overcome jamming. So it gets into some jamming range, and now the person with the goggles can no longer manipulate the drone, but the drone has an algorithm on board to maintain target recognition and do the finish. Very, very tightly bounded by time and distance. The drone can only fly for so long. The distance is only so far. And then the dimensionality becomes relatively low because that has a pretty singular mission. We're not asking it to remission itself and recognize something that needs, information that needs to be propagated backwards. It is, you have an algorithm that tells you that that's a tank, it's a Russian tank, you're allowed to execute the finish on that. That's where I think the evolution goes.
Yeah.
I hope our enemies are trying to replace humans in very complex environments, because I don't think that those lessons are scalable or transferable backwards when trying to maximize human cognition, and they'll be chasing something that can't be done right now.
Yeah.
I'll add one more kind of layer to that, and I think it's reliability. For the tools and the workload offset that I've talked about, the operator doesn't care how it's learned to do its job, whether it be machine learning or just a deterministic algorithm. I just want it to work every time I do it. And we need to make sure that the tools that we give them are reliable, at least as reliable as humans are, if not better, or the machine that they're used to using. So if we replaced an algorithm on the F-35 that was now 75% accurate instead of 90 at doing its task, no one's going to like that, and they're going to stop using it immediately. So that reliability piece is a real challenge, at least in my experience recently, having lost my Tesla to a self-driving incident. It has its faults.
Yeah.
So that was one thing on a roadway, didn't hurt anybody, it was great. But when you're talking about life and death situations, which we often are, even on our roads, we have to make sure that it's up to a certain level of standard. And testing it is hard when we're talking about exquisite, expensive weapon systems where we only get a few opportunities to hit a certain test point. And then we have to hand it off and hope that it's working. Those are going to be the challenges, I think.
Yeah. Okay, so let's talk about the future then, with some vision and innovation. Can you tell me and our audience about how the Air Force adopts and acquires new technology and supports innovation, and ways that you're trying to match the pace of new technology and particularly AI?
I mean, the general system of how the Air Force buys money is to identify a need. Sometimes we do that through the war planning process or tabletop exercises or actual practical experience. And then we say, the thing we need is this. The dangerous time is when we, say the thing that we need is this really exquisite platform to answer this scenario that we kind of imagined may occur and the president may ask us to solve, because you're making a long chain of easily falsifiable and highly dependent assumptions to generate the scenario that you think you're going to need the thing for. That can lead you down a road of like procuring something that is like overfit to that scenario, and it's easy.
The baby formula.
Yeah, exactly. And then this becomes really dangerous. And so, kind of what our approach is, let's talk to the warfighter or talk to the operator, and then really try to get to the point that we can understand the problem in a way that we can define it and then solve it via a first step in research, in fundamental research, who's an applied research partner or who's an actual commercial provider who can provide something to, or help us solve that problem. But that's not the traditional acquisition process. And so we do have some non-federal acquisition regulation ability to put those kinds of things on contract or to get that research done. But that's what we're trying to evolve to is, how do we field things fastest off of experience, and how do we define the thresholds of success for those things?
I'll say that there's a lot of opportunity, and it's fun and exciting and scary and emotionally driven to think about autonomy and AI being used in combat situations at the very edge where it's going to be maybe augmenting the human and hitting the pickle button to release weapons. But there's so much of a need in the bureaucratic side of the government, and that it could help. It's shocking how antiquated our systems are in terms of just the software we use to give people orders, to pay people, to execute our administrative duties. If all that was just me querying a chat bot to look at all the regs and tell me what I can and cannot do, and then when I make a decision on the options, I say hit go and it just happens, it would save so much time. And that would then free up our time to be doing more strategic thinking instead of paperwork. And that is where I think the lowest hanging fruit is to really revolutionize it. And I don't think it means that we are going to be displacing a ton of jobs, because we still need people monitoring to make sure that those are being executed. But if those people are now just monitoring the events happening and maybe just making sure that nothing goes off the rails, there is a lot of opportunity to, I know, help me in my job as commander to be focusing on people instead of paperwork and process. And that would be amazing. And that's one thing we're never really going to be able to replace. I can't imagine any AI algorithm being able to walk into my squadron and read the look on everybody's face and tell me what they're feeling today and how I can best lead them. I don't think I've met that chatbot yet.
Yeah, I mean, a systemic fundamental challenge that the government has is the incentive structure. I mean, bureaucracies and governments are built to ensure compliance and ensure that there's no fraud, waste, or abuse. I mean, all these kinds of checks and balances run, kind of in tension with the rapid fielding of technologies that may or may not displace, something that has a lot of stakeholders behind it. And so you're rewarded in the government for compliance and for legal checks and those kind of, what is exactly what a bureaucracy is for. And so it's hard kind of outside of just individuals who like to get things done to incentivize risk-taking, in ways that aren't systemically reinforced through incentive structures.
Yeah. Well, like Raven mentioned, AI for helping bust through some of the red tape and paperwork. Jason, what's a technology item on your wish list, your AI wish list, that you would like to see, whether it's something you would touch or that would be out in the field?
I mean, we have a few projects at the studio. Certainly, vision-based navigation is something that we really want. Automated target recognition. I want to work distance estimation and refueling because I think it's it's kind of the very first start in the ability to do autonomous refueling. So we're really focused on understanding the need enough to know what is holding back the frontier of the next level of effectiveness. And so, it's developing the technologies to answer those problems. And so, it might seem not as cool, but I don't have a sense of like, this is the AI tool that's gonna like solve all the problems, because I just don't know what those problems are yet.
Yeah.
And so I really like the idea of building the tool that makes us better, to move us to the next level, so we can now reimagine an order of battle in some way different that highlights the next frontier, the next frontier, the next frontier.
Yeah.
I think those are done by rapid acquisition and rapid fueling of technologies.
Yeah.
My wish list is to actually have the capability to onboard anything that's modern. And what I mean by that is our requirements process and where the compute on our aircraft is frozen is over a decade ago. And when we have our modern compute is 1 million times more powerful than it was a decade ago, we have a problem.
You said in the F-35, it's like your cell phone, the amount of compute on that platform?
I mean, it's probably less than your best cell phones. It's a fantastic platform, but it's just the way the requirements work. And we need assurance that the computers on there are going to work through all sorts of terrible situations, but that doesn't allow us to onboard modern applications that will maybe solve a certain tactical problem. So my dream is to have the compute available at the edge to be able to solve whatever problem is presented to us, and have the methodology, the process to write a software application, bring in a new agent, whatever it may be, for auto-target recognition, something we haven't even seen before, and get it out to the field in a matter of weeks, as opposed to the process we're constrained in now. So that's my dream. And I think the problem is we're so far away from the specific question that you're asking that we just need the sandbox to even start understanding what the art of the possible is and what tools are going to be good at the front line and which ones aren't. And our warfighters are going to very quickly tell us that we picked the wrong thing, and we better be able to go grab a different color rock and bring it rather quickly to solve their problem.
Yeah. And we have really big challenges in data infrastructure, the kind of like, we just never built these sensors or these platforms to record, produce, and make available data that's modern, useful, and doesn't require a ton of manual labor to disaggregate and put to some kind of use.
Yep.
I'll give you one very specific example. Our targeting systems use very simple algorithms for tracking a car or an aircraft or whatever it may be. Very manual. I grab a certain color of pixel on a screen and I say, I want you to follow that. And then the car goes under an underpass, or something goes by another car going the other direction, and it grabs that one instead. And now my workload goes up because I have to drag my cursor to the right vehicle and continue to prosecute that attack or monitor. There's better ways to do it out there.
I know a company that can help you with that.
Kind of, yeah. So getting those modern tools into our weapon systems is critically important, so that the pilot doesn't have to focus on just that one task. They can be avoiding getting shot. They can do other things that will enhance their lethality and their survivability, besides that very, very simple task that should be simple, but it's still not.
Yeah. Any last points or things you wish I had asked you but didn't, before we see if there are any questions from the audience?
I'd love some questions.
Yeah, we have questions.
Okay, great. Any questions for our panelists here? We might have all the microphones.
If you guys can share, I'll take one. Hi, I want to ask about the supply chain situation. You mentioned you saw the Special Forces reaction to what's able to be produced US domiciled. And what I'm looking at from the innovation side is a question of the parts are like so much more expensive, so much longer lead times to produce, and various factors in being able to get the parts to actually innovate fast enough in a truly US domiciled supply chain. Do you think there's any solution to approach this that's like not just, oh, we need to do a better job of identifying and validating who needs to get that funding because of the drag time on that? I mean, what's the path to really drive more innovation that can be US domiciled?
I mean, one of the research vectors that we have at Stanford is modeling and simulation. And I think that's part of it, is building a domestic, modern manufacturing process that can do modeling and simulation better and get to prototype faster, maybe through, it doesn't have to be 3D printing, but some kind of advanced manufacturing capabilities. Because I think what we really, maybe one of the lesson from Ukraine is mass is going to be a big part, mass meaning like lots of stuff, is going to be a big part of winning whatever the next war is. But it's not just mass. Like we've had mass before. North Korea has a lot of mass that holds South Korea at risk through artillery. Right? That's not going to win our next war. So I think it's, can we build mass that's both dynamic and has range? And the way to do that is that's a kind of a demand signal, hopefully, to build the kind of industrial base that we need to answer that question. The other would be to just kind of draw boxes about where and what we're willing to field that we don't have a ton of confidence on in the supply chain, and accept that the bigger risk would be to not have the thing that you need than it would be to know everything about the thing that you need.
I think the last part is really crucial. There's a risk and a cost to not advancing technology, and we've already bought that risk because of how we've done things forever. I'm not saying we should put Chinese components in every weapon system or every part of every weapon system, but the cost of not moving quickly is upon us, and we need to now overcome it. I think we need to name the monsters under the bed instead of just being scared of those monsters. They're nuanced. We should figure out what components we care about and which ones we don't, and are there ways to mitigate it? And certainly a single supply chain, even if it was US-based, would also have its significant risks. The least of which would be just creating a monopoly, and now we're paying whatever that price point is. Like, we have to avoid all those pitfalls of being draconian about it. Now, should we be concerned about supply chains? 100%. There's lots of nefarious things you can do with them, but we can't avoid forward progress as a result of that fear.
And there's no perfect supply chain.
Last question.
Thank you. This is a very different sort of question. So I've noticed that a lot of youngsters these days, like my son included, heavy in gaming, right? And a lot of the concepts are, like physics-based and others. So he plays like there is a game that you build sort of satellites or airplanes and others, and there's another one that does, I don't even know the gaming well. But how do you harness that intellectual capacity that we are gaming? Like this guy spends like 8 hours, he's in university, but spends 8 hours in gamings. But I think there is a way to harness that in a simulatory fashion, whether it is flight simulator, so that they can become like experts in drones and other things like in the future. What do you think is done and what should be done going forward?
My son loves the games as well, and it's made him very good. He can fly our aircraft, take off to touchdown at 8 years old because of flight simulators. So there's certainly utility in it. And how do we harness that? I think we gamify things that we want our future generations to have deep knowledge in. I mean, I wish there was a game that taught me Python back when I was a kid. That would have been great, because I don't know how to do that.
These days you can write Python using English.
You can, yeah. So maybe now that time has passed. But I think understanding the strengths of that high-end-eye coordination, even the mission planning aspects of it, Ender's Game, right? That our savants of the future may be controlling the battlefield in a similar way. We also need to understand the weaknesses that brings of not having human interactions as much because we're behind our screens and on social media and in our echo chambers. It may make us not as good at leading people in hard times. It's really easy to be a great leader when everything's going right. When everything's going wrong, you got to dig deep and figure out how to keep people going, and that's hard to get from a video game.
I think that's an excellent point. And I think we should thank my 3 favorite pilots one more time.